This is the formula sheet from the SAT. We'll look at each of the equations and make sure that you're comfortable with them. So first of all, we have a circle and we have two equations related to the circle. The first, A equals, so always A will always mean area. And then we have C equals. So C equals is a circumference. Let's look at the area first. Area is equal to pi r squared. Whenever necessary, you can sub in the value for pi. We usually do 3.14. If you need to be very accurate, you can do 3.14159. Or you can just use the pi button on your calculator, if you're allowed to use a calculator, and you'll get a more accurate answer. So in general, you can do area is equal to 3.14 times the radius squared. If you're given the diameter, you might have to do a little bit of work to get the radius. So if you were given the diameter instead, say you're given d is equal to 6 centimeters, you need the radius here. The diameter is the whole way across, radius is half of that, radius is equal to 3 centimeters. Divide the diameter by 2 because radius is equal to diameter divided by 2. So sometimes it's helpful to be able to sub in that value. Okay, the second equation for the circle is the circumference. So circumference just means perimeter. It's like you walk around the outside of the circle, how long is that walk? And this one's 2 pi r, or we can also say that the circumference is pi d, because 2 times the radius is equal to the diameter. Okay, so that one hopefully is one you've seen recently enough and you remember it. You probably did it in grade 9 and before that. Next we have a rectangle. Fairly straightforward. The area is the length times the width. They haven't given us the formula for the perimeter. Should you need it, it's just width plus length plus width plus length. Perimeter would just mean going around the outside. Okay. Sometimes in questions, instead of being given the length and the width, you might be given the area and one of the other dimensions. You might have to isolate the variable. So if you need to isolate, say, the width, if you're given the length and the area, you would simply, if you want to get the width by itself, you would divide by the length, and you'd end up with width is equal to area divided by length. Okay, next up here we have a triangle. So triangle, very easy, base times height divided by 2. And if you're not given the height, if you're given the side, maybe it could be a right triangle, you might have to use Pythagorean theorem to find the other side. So here we go, we have a Pythagorean theorem, so I'll write that. Pythagorean theorem, short form here, THM. And it tells you if you have a right triangle, a triangle with a 90-degree angle, the sum of the squares of the shorter sides, a squared plus b squared, is equal to the square of the hypotenuse, the longer side. So this is a very useful formula in everything from trigonometry to just calculating areas and volumes. Next we have the special right triangles. We'll talk about these a little bit more when we talk about trig, but basically when you're given angles, you can find the sides, and for these triangles, they work out to be exact values, which is very helpful. Okay. Down below we have some volume formulae, so let me just make a little bit of space. So first, the volume of a rectangular prism. It could be a cube, or maybe the length, width, and height are not equal and it's just a rectangular prism. Length times width times height. Just be careful you don't take 2 widths and 1 height or anything like that. Make sure you get the 3 different dimensions here. Next is a cylinder. Volume is equal to pi r squared times height. Remember always to get the radius here, not the height. Basically, it's the area of that circle times the height, pi r squared times height. Volume of a sphere is just in terms of the radius, 4/3 times pi times the radius cubed. A cone here, so h is the height it has to be perpendicular to the radius, 1/3 of pi times radius squared times height. And the final equation given is the volume of a rectangular based pyramid. So notice here that we have a length and a width, and then the height is perpendicular to that base. So in this case, it's the length times the width in here, so that's the area, times the height, and it's 1/3 length times width divided by height. It's very closely related to the rectangular prism. And again, for all these volume formulas, you could be given the volume and be asked to find the radius or one of the dimensions of the side or all the dimensions of the side, and that just might involve a little bit of algebra to simplify. On the formula sheet, there's also 3 more statements that are made. The number of degrees of arc in a circle is 360. So that's just telling us that in a circle, it's 360 degrees to get all the way around. And in radians, it would be 2 pi. So we'll talk about this a little bit more. It's just another way to express these units. Instead of talking about degrees, we can talk about radians. The sum of the measure in degrees of the angles of a triangle is 180 degrees. So we often use a slightly different set of words for this. We usually say the sum of the interior angles of a triangle add up to 180, and that just means that for any triangle at all that you draw, if you add up these angles on the inside, let's call them x, y, z, they always equal 180 degrees. X plus y plus z is equal to 180 degrees. Okay, so this can be very helpful. If you're given 2 of the angles, you can find the third. Okay, and this is the formulas that you're given on the SAT.